Hi everyone, we are going to present Mojin, a library of multi-objective reinforcement learning environments. In reinforcement learning problems, an agent interacts with the environment with the goal of maximizing a discounted sum of the rewards it receives. A key feature of this framework is that it can be used to model many real-world problems. This brings us to many success cases of RL in different domains, such as reaching human-level control in Atari games, beating the world champion of the complex game of Go, and making a robot learn to walk in under 20 minutes of training. But how did we get here? Gin has been a key and central part of this history. It was installed more than 35 million times and is the most used RL library in the world. It presents a standard set of environments which are widely used in the research community. It introduced a standard API for communication between learning algorithms and environments. For instance, the make and reset methods are responsible for initializing the environment and returning the initial observation. The step method is the most important method and is responsible for returning the next observation, reward, a flag indicating whether the episode has terminated, and a dictionary of extra information. However, most real-world problems involve multiple conflicting objectives, such as energy, safety, and efficiency. Even so, in standard environments, the trade-offs are usually handcrafted by trial and error. Here, we show an actual part of the half-sheet environment code where you can notice that one of the reward components is being weighted by a hard-coded value. Then, even the reward being multi-objective, it is being scalarized without taking into account how different weights can affect the agent's performance. To show the impact of using different weights in a multi-objective environment, here we show a graph where each point corresponds to the return of the agent for the two objectives in the half-sheet environment. In the x-axis, we have the velocity objective, and on the y-axis, we have the energy consumption. As you can see, depending on how we prioritize the different objectives, the cheetah learns a different behavior with trade-offs running faster or saving energy. However, this type of control is typically not possible with current RL benchmarks. We fill this gap by introducing Mojin, which extends Gin's API to support multi-objective reinforcement learning. The key difference is that in Mojin, the reward is a vector containing multiple objectives of the agent. It introduces new wrappers tailored for multi-objective RL, such as scalarization functions, and it currently includes 11 different environments, which are going to be further extended. Mojin is publicly available on GitHub. Mojin environments include classic multi-objective environments found in the literature, as well as multi-objective extensions of classic reinforcement learning environments.
Hey, Florian here. So now I will show you a little demo on how to use Mojin to play with various benchmark environments. So the first step to play with Mojin is of course to import the libraries. And in this demo I will use Gim, and of course I will import Mojin. The second step is to create an environment, so the problem we want to play with. And you will see the API is very close to the one from Gim. Actually, to instantiate an environment, I can use mojim.make and put the ID of the environment I want to play with. Here I want to play with a multi-objective version of the mountain car problem. So as a third step, I can dig deeper and extract information from my environment. For example, the observation space is what my agent can perceive. So here I can extract it to analyze it, and my action space is what my agent can do. And the new thing when compared to Gim is that we have a reward space which characterizes my reward vector as well. So here we can see that we have 3 objectives, and every component in the objective goes from -1 to 1. And then I can show you also how to use features from Gim in Mojin, because everything stays retro-compatible, so that we avoid to re-implement everything once again. So here I can show you how to use the wrapper to record videos of our agent being played in the environment. So I just trap my environment into the record video wrapper. I put the folder where I want to save the videos. And I put a trigger which will tell the wrapper whether or not it should record this episode. And yeah, so it will record all the time because it's a demo. So yeah, the last step is to instantiate an agent to play through our environment. And I will just instantiate a random agent in this case. So the first thing to do is to reset our environment to start from the starting state. And I'm using a loop to play one episode. At every iteration, I'm rendering the environment to make sure we can see it. And just here I'm catching the returns from the step method, and you can see that the reward is a vector. And yeah, so I'm sampling action from the action space to get random actions. So it's a random agent. Finally, I'm rendering again to get the final state of the environment. Let me render it. Yeah, there we go. So we have the mountain guard that is being played by a random agent. Awesome. And yeah, so we can also see that the video has been recorded with the wrapper from Jim. And yeah, so everything works fine here. And finally, what is for me the most amazing thing is that we just have to change the ID of the environment to play with a new benchmark problem, which will help to test algorithms onto various problems, I guess. So here, yeah, I'm playing another environment without the need to change my code.
To summarize, we introduced MoGen, a standardized API for multi-objective reinforcement learning and an extensible repository of multi-objective MLP implementations. It is a step towards a solid base for reproducible research in multi-objective URL. As future work, we are developing multi-objective reinforcement learning baselines, a repository of multi-objective URL algorithms implementations compatible with MoGen. Thank you very much for the attention, and please check our GitHub for more details on MoGen.